Hey ho! It is still Math 2, still coordinate geometry. Today we're jumping into lesson 13. Today we're really talking about intersections. So it's really about circles and how they intersect with lines. So if there's a circle and a line, it's all about these points. Where do they intersect? And with that, here we go. We've got the equation of a circle, so we can draw some of these circles. We can take a look at them. I'm going to skip right over to Desmos here. You can look at the problem itself and say, that's nice. You should be using a compass to draw a circle, or at least getting close. Otherwise, this really doesn't work. But I can see if I draw on this, there's my H and my K. So my center of my circle is going to be 3, 2. And if r squared is 25, my radius is going to be 5. So that's the first part of that. And then we're looking at this line, y equals 6, and we're looking at the line y equals x minus 2. So let's head over to Desmos. I'm going to spare you my art skills today, and we're going to put it right onto Desmos where we can see it. So I graphed it with a graphing calculator, and there's my equations. And you can see, so let's talk about this for a moment. Let's dig in here. They don't really show us the circle there of 3, 2, but if it's 1, 2, 3, 1, 2, it's really right there. And then we're taking a look at drawing this line y equals 6. Okay, this is y equals 6 right here, because it's y equals 6, y equals 6, y equals 6, 6, 6, 6, 6, 6, 6, 6, all the way across. That's a horizontal line. And where does it hit the circle? We can actually see that. We can see it hits right here and right here. So it hits at these 2 points. So that intersects the circle at 2 places. And I can actually get those coordinates just by looking at it. So your graphing has to be accurate in order for your answer to be accurate. And by the way, use Desmos. It's a good thing. I highly recommend it without a compass. So if you're at home, you've got technology. Don't be afraid to use it. So I'm going to hit at, looks like 0, 6. And I'm going to hit at 7, 6. It kind of makes sense. If I really were to actually draw a triangle right here, I would kind of see that idea that there is something going on with right triangles there too. It's kind of a 1, 2, 3, 4, 5 thing because the radius is 5, and that's a 3 and a 4. It's a Pythagorean triple. So those nice, easy round numbers on that one. It's not always going to be that way, but we'll take it when we can get it. And then we want to graph this other line. We want to graph the good old y equals x minus 2. That's got a slope of 1 and a y-intercept of negative 2. There's the y-intercept down there. There's the slope idea of 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1. There you go. So kind of see that all the way around. That was really unnecessary, but that's okay. And then we're taking a look at, okay, what points does it hit at? So we can see them. They're right there. We can see where it's going to hit. Can we verify it is the question. And that's the big question. Showing your work is to verify these things. You got to do the work. You'd actually have to put in, I'm going to erase this for a moment over here. You would actually have to put in x and y into your equation. So you'd have to go to your circle equation, x minus 3 squared plus y minus 2 squared. And it equals 25, so we're just going to leave the 25. That's what we're trying to equal here. And you have to put in, if you're going to use 0, negative 2, you'd have to say 0 minus 3 squared. That's going to be negative 3 squared. That's going to be 9. And then minus 2, negative 2, negative 2. That's going to be negative 4. And square it, you're going to get a positive result. You're going to get 16. Well, 9 plus 16 is 25. Therefore, that proves that that point is on the circle. So that's the verification process. Take your equations, sub and evaluate, folks. Substitute, oops, not that sub. Let's substitute a pen there. Substitute and evaluate. That's how you verify, evaluate. That's how you verify. You prove that it's on the circle mathematically. All right, here we got another one. We got us another circle. Can we get the equation for it? I'm sure we can. Let's do this. So this one we don't have to draw. It's already there. This is going to be x squared plus y squared equals, what's the radius? 10 squared, so 100. That's r squared. There's no plus or minus h and k here because the center of the circle is right there at 0, 0. So there really isn't anything extra. So they're asking us to take a look at a couple different situations. So let's take a look at those situations. Any line parallel to the x-axis that intersects the circle at 2 points. Parallel to the x-axis. You can just check. Let's see, I'm just going to make one right here. I'm going to choose that line right there. We need to choose y equals 6. So parallel to the x-axis, it's y equals 6. And I can take a look at the points on that line. I can say it looks like it hits right here and right here. So I can say that's what I think is going on. And it looks like it hits at the points. If I give it point, looks like it hits at -8, 6, and 8, 6. Can I verify those? In other words, if you're going to verify it, you'd actually have to take those coordinates, x and y, put them into your formula there. And you can see 8 squared is 64. 6 squared is 36. You can see that that's going to add up to 100. So you can see that those points are clearly on that circle. So we can verify them like that. That's the verification process. How about a perpendicular line? Let's go the other direction. So what's happening there? So going perpendicular, we can take any perpendicular line. Let's go right here just for the sake of argument. And now I can, once again, I can see where my points of intersection looks like right here and right here. So I can kind of see where they're at. So it looks to me like they are the points 4, 5, 6. 6, -8, and 6, 8. Once again, if you're going to verify those, guess what we're going to do? It's the same thing as this, 6 squared and 8 squared. So it's really the same thing we did right over here. I'm just highlighting that real quick. You're just doing x squared and y squared. This is a nice, easy, clean one because there's the center is 0, 0. You don't have to do a lot of number work. And then we can go all out here, full on line assault here. Forget the vertical, the horizontal. Let's get sideways and diagonal. We got this idea of the line y equals -1/3 x plus 5. So it's -1/3 x plus 5. That means it hits at plus 5. That's got a slope of -1/3. So I'm going to down 1 over 3. 1, 2, 3. Down 1, 1, 2, 3. Down 1, 1, 2, 3. And I can make a line in there that's going to be my line. Except that I want to really get it to where it hits the entire circle. So I'm going to have to draw. It's really tough to draw on this one. So I may go to Desmos on this in a minute. So there's the line. It looks like it's got points of intersection right there on the circle. The question is, what are those coordinates and then how do we actually verify them? Do I have a Desmos for this? I do not. So that one, I'm just going to have to guess for a moment. I'm going to just kind of do a little bit of a guessing game here and say, I think that's the point -6, 8 right there on the top. And I think this point over here looks like 10 and 1. So I could actually verify that using the Pythagorean theorem. So that's the idea. We can verify it. All right. How do you know it's on the circle? Verify it. All right. That's our lesson, really, just drawing circles, drawing straight lines, vertical, horizontal, and diagonal, and finding those points of intersection and verifying them. Don't forget, we are verifying them. That's part of the process. So you can kind of see where the show your work portion of this comes into play. All right. Let's take a look. This was one of the ones we looked at, I think, in the homework. I'm looking at this center of the circle here at 2, -3. So 2, -3 is right there. And I'm looking at the line x equals 2. And I'm seeing that the radius is 6. So if I just count 1, 2, 3, 4, 5, 6, I'm just counting my way back to the top. And if I go the other direction, 1, 2, 3, 4, 5, 6. So those points are clearly on that curve. So that one, in some cases it's obvious. Some cases you need to do a little math. And if you need to do a little math, that means you just got to kind of take the top point there, like 2 minus 2 squared plus y is 3 plus 3 squared equals 36, and check it. 2 minus 2 is 0, so that cancels out. 3 plus 3 is 6 squared. Well, we know that's 36, so we're just going to say, yep, we're in there. So verification. Don't forget to verify. And we can do it with parabolas too. This is kind of a review problem, but let's see. They're checking this parabola. There's the focus. There is the directrix. Focus is 3, 4. So let's see. 1, 2, 3, 1, 2, 4. So there's the focus point. That means the directrix, let's see, is y equals 4. We're just verifying points in parabola. So let's just see y equals 4. There's a line there, and we're just checking these points. Checking that point there, that point there. So we can actually verify if we have the equation of the parabola. It's cut off on my screen here, but we could write that equation, that parabola. I can write it in vertex form, I think. You know what? On that one, I'm going to leave that for you for homework on this one. We're going to call it a day, and I know Forbes ain't around, but and I cannot be him. See you, CDM.